So we're still using geometry to find area under curves. We're going to break away from that very soon, next lesson. But really, that's all that we have. So we're going to geometry here. X plus 3 is a line. So let's just look at this. X equals X plus, equals X. And so we would have went to 1, 2, 3, and 1, 2, 3, 4, 5, 6. We're going to go in slope of 1, slope of 1, slope of 1, and we go from 1 to 4. Okay. Oh my gosh. I was looking at an angle here, so I'm going to have to choose a different color now. Oh my gosh. All right, so 1, 2, 3, and 4. So that after here. We want that. And just use geometry to do this. This is a trapezoid. So from 1 to 4 of x plus 3 back to x is actually half of this base, which is 1, 2, 3, plus 4, 5, 6, 7, multiplied by 1, 2, 3. The height. So I get 1 half times 11 times 3, 33 over 2, which is 1, 16 and a half. That's it. Nothing else to do. And why did I screw that up? Oh. Yeah, no. I didn't screw it. Panicky. It's stupid mistakes. All right. So we have a function y equals radical 4 minus x squared. All right, so now you can just plug it in a table and graph it and see what it looks like. Go to Desmos, graph it, see what it looks like. But I'm actually going to use algebra here. I don't know what that looks like. I'm going to actually square both sides here. And when I do that, I actually make y squared. Now that is a kind of not a tendency for people to want to do, because y squared, we want y to just be by itself. But if I square this out, look at what we can do. If I move this guy over to here, I get x squared plus y squared equals 4. Now, if you remember from pre-calc, this is actually the graph of a circle. In fact, it's a circle with a radius of 2. All right, so what we've got is we have that. And we want the area from -2 to +2. All right. Now, the thing with this, though, is that me drawing this underneath here made it not a function. Like, I only want the square root. I cannot have negative values of y. So this is garbage down below the x-axis. What I want from here to here, that's all that I need, okay? And so when I actually figure out the area from there to there, all I have to do is think, well, area equals pi r squared. The radius is 2. That's 4 pi. But that's the whole circle. So if I want the half of it, No, I'm sorry. It's late. If I want half of that, the actual area is 2 pi. All right. So that's that. We're using geometry basically to just find areas. That's all. And the whole point of this is to make sure that you understand that, you know, it is just geometry. And if you need to draw a graph to find those areas, fine. All right. All right. So here we have, let's see, we've got an absolute value function that's being raised. It's being elevated 3. 1, 2, 3. All right. So we have that. We have that. And we're going from -2 to 4. Okay. All right, now all I have to do is figure out the area of these two trapezoids, and I've got it. This is trapezoid 1, and that's trapezoid 2, right? So all I have to do is find those areas. I'm going to do them separately so that trapezoid 1 is actually going to have a base of, I'm going to reorient these so that it's 1, 2, 3. I don't know how high it went. And -2, 2, it's going to be 5. So it's as high as 5. So take 1/2. 5 plus 1, 2, 3 multiplied by 2. And then the other trapezoid is 3. So remember, take half. Take the average of these bases. Now if I plug in a 4, I actually get 7. Okay, so 4 plus 3 is 7. So that's the height up here. And then we're going to have the same width. Nope, width is 4. Nope, 1, 2, yeah, 4. All right, okay, so add those two areas together. Let's get the total here. That's 8, 4, 8, 5, 20. All right, so if I were to add those two areas together, I should get 28. Let me verify my answer, and it's cool. All right, so this is the geometric way to actually find the areas underneath the curve. All right, so now we have the cubed root. I hope you remember the cubed root from all the families of functions that we studied in pre-calc. All right. Cube root of 0 is 0. Cube root of 1 is 1. Cube root of 2, decimal. Can't do a cube root until 8. 1, 4, 5, 6, 7, 8. Cube root of 8 is 2. And this is going to happen all the way to the other side as well. So if I go all the way to 8, I'll have a point there. What's the area? It's an odd function. It's an odd function because it's symmetric to the origin. All right, it's an even function. So therefore, if I were to calculate the area of this, calculate the area of this, it's odd. It's 0. Okay? All right, we have another line. No problem. 1, 2. When I go over 1, I go up 3. Go over 1, up 3. Nah, it's going to make me be careful. 3. Now I'm going to 4, so I got to go up again. All right. So something like that. All right. So I'm going from 1 to 4. This looks terrible. Okay, but that's the idea. So how high do I go up The area here is I'm going from, when I plug in a 1, I get 5. When I plug in a 4, we get 14. Multiplied by the distance, the width, that's 3. So that's 19 divided by 2, times 3. So, what is that? That is 57 over 2, which is 28.5. All right, last one. This totally sloppy trapezoid. I get it, but if you have any questions on how you got 5 and 14, let me know. Just, we're plugging in 1, and then we're plugging in 4. All right. So we are going from 0 to 2 with this guy, 2 to 5 with this guy. All right. Whatever. We can figure it out. We're going to go ahead and do kind of like a part 1, which is this guy. All right. And what we did here is we have a circle again, half a circle with a radius of 2, but with the plus 1, we've raised it up 1. Okay. Nope, not 0. 0. Okay, so from 0 to 2, raised up 1, we have 2 pictures here. That right there, if you remember from the previous example, this guy, it's actually 2 pi. So if I want a quarter of it, quarter of the full circle, then I'm actually just at pi. So quarter here is pi. That's the area. But I raised it up 1, so then I have this block that is actually 2. So that area is just pi plus 2. Okay, now that's the first area. Now that's this guy. Now the next guy goes from 5 to 2. Now this 3 minus x is just a line, so let's graph him. They're pretty lengthy, and that's why, this is why when we get into the next stuff, the next section, you're going to just be able to do this algebraically. Drawing pictures freehand like this is obviously so much room for error, as you can clearly tell. If I started off at 3, the slope is a -1. And we're going from 2 to 5. So 2 to 5 is 4, and then it's 5. Okay, so 2 is here. That guy right there, that area, we got an issue. I called it A1. Let's call it A2. Our over 1 went up 1. And if we use the area of a triangle, that's 1/2, right? Because we get a 1 by 1 divided by 2 is a half. Now this piece here is actually, let's see, when we plug in 1, 2, 3, 4, 5, 5, -2 times 2 is -4 cut in half. It's -2. So this means I've got -1/2. Oh, they did a different thing there. I did this different than what the answer key said. So that always startles me, when my common sense doesn't quite match something else. But maybe you see this a different way, which is clearly what the answer key, which I like to keep with me because I know that there can be other angles in this more complicated stuff. So that's really -3/2. That's what they have as well. Now, what they did is they actually split this up. They did this. And I didn't see that necessity. What I did is I did not see this at all. I saw a line here. And so that's when I graphed this. All right. Now, this, you would never do that because we're going to take what's called the antiderivative of this, and things would be so much easier. But this is what the answer key did. So maybe you saw it like this, and that's cool. I just want to throw that alternative. But this is the way that I saw it. Two triangles, one, this negative triangle larger than the positive one. And what we do is we add those two together. So, well, really, it's like 1/2 minus 2. Like this is a -2. So if I were to add those two, I would subtract. So I end up with this. Now when I add all of it together, I end up with pi plus 2 minus 3/2, which is just pi plus 4/2 minus 3/2, which is pi plus 1/2. All right, so that's it. That's the game. Geometric way of looking at things. Other than that, we're going to be learning some techniques that will speed these up. You do not have to draw pictures. We can just go to the straight algebra. All right? Enjoy. Now, at this point, you can do all of the problems in 6-4, all of them. Not quickly, but you can do all of them. So, look. If you want to do like a Google Meet, let me know. Just email me, use my Google Voice phone number, whatever. Just, communicate. We can go over something. Dude, it will take like 5 minutes, and then everything will gel. All right. So, all right. Have a good night. I'm so tired.